Write once, run anywhere. This is every Java developer's wet dream, but it looks like it is going to be Kotlin, Java's younger, smarter and prettier sister, who's going to deliver on this promise. Kotlin was picked by Google as the default solution for building Android apps, has amazing support on the server through its Spring integration, and now, thanks to Kotlin multi-platform, you can write your code once and then run it on the server, mobile devices, desktop and the web. Knowing Kotlin is a great asset these days, and learning it is easier than you might think. So let's not waste any more time and look at some Kotlin code. There are a couple of details and conventions you should be aware of from the get-go. First, Kotlin is built on top of the Java virtual machine. The JVM operates on a platform-independent binary format called bytecode. This is the glue allowing your code to run on any device equipped with a JVM. So let's go ahead and install both Java and Kotlin locally using SDKman. Then, in a new file, I'm defining a basic hello world function. Back in the terminal, we'll use the Kotlin compiler command to pack our code and the runtime in a jar file, which can then be executed on the JVM. Of course, since both Java and Kotlin share the same platform, Kotlin code can easily interoperate with Java code, so you'll get all the benefits of both a modern language and a mature, battle-tested ecosystem. Okay, now that we know how to compile and run Kotlin apps, let's go back to our file and write something a bit more interesting. The main function is the entry point into our program, and in here I am going to iterate over an inclusive range, initialize some movie objects from data entered in the terminal, and add all those objects to a list. Then we'll filter out movies with a score smaller than 5, map the list of movies to a list of names, and finally print each of those strings. While this code might not look like much, it actually uses a lot of the features that make Kotlin such a great language, so let's look at them in more detail. At a first glance, you should notice at least 3 of the main concepts behind Kotlin. First, there is a high emphasis on immutability, which is a must when developing modern scalable apps. If you really need mutable properties or variables, you have to use the var keyword. The same goes for data collections, where we had to explicitly use a mutable factory function. Second, in Kotlin, types are non-nullable by default. This means that you cannot assign null to a variable unless you explicitly declare it as nullable. This is a great mechanism to eliminate the dreaded billion-dollar mistake. The development experience is also enhanced thanks to the safe call operator, which allows you to safely access a property or method of a nullable object, and the elvis operator used to provide default values if expressions are evaluated to null. Finally, Kotlin is strongly typed with a compiler that supports type inference, explicit conversions, smart casting, and generics. While smart casting is a really great feature that allows you to remove some of the boilerplate, we should probably briefly discuss generics in more detail, since you'll definitely run into them whenever working with Kotlin collections. This might not be obvious thanks to Kotlin's type inference, but trust me, those types are still there under the hood. Generics allow you to define types that have other types parameters. When an instance of such a type is created, type parameters are substituted with specific types called type arguments. Also, note the use of data classes, which provide a concise way to create structures that hold data. While this doesn't look like much, it makes a big difference especially for developers with a Java background, since methods like equals, hashcode, toString or copy are auto-generated. On top of all these, you get access to generated component functions, which allow you to destructure objects. Another convenient feature when working with classes is the use of object expressions. This is useful when you need a quick way to specialize a class's behavior or to implement an interface without declaring a full class. While tempting, you should avoid overusing object expressions for complex structures or behaviors that are used across your application. By the way, you'll see throughout this video that Kotlin goes out of its way to provide a clean yet expressive syntax to improve code readability. For instance, we can use name parameters when calling functions and constructors, which solves the problem of long lists of function arguments, which are pretty difficult to keep track of. Before moving to more advanced concepts, let's quickly mention some of the functional APIs exposed by Kotlin collections. The functional style provides many benefits and is one of the main mechanisms you can use to simplify your code. The filter, map, and for each functions form the basis for manipulating collections, and they accept both lambda functions and function references as arguments. The easiest way to see the value in some of the advanced features employed by Kotlin is to look at a list of examples provided in the Kotlin in Action book, which, by the way, is a must if you want to get a good understanding of the fundamentals. Through extension functions, you can easily extend classes without having to inherit from them. Properties can also be extended, and note that extensions do not actually modify the extended classes. They provide a way to call a function on an instance of a class as if it were a method of that class. Kotlin's infix notation is another useful little language feature which allows your code to be more fluent and intuitive. The only constraint is that these functions must have a single parameter. Overloading operators is a common feature in modern languages, and Kotlin also supports this, but with a couple of caveats that remove the complexity and increase maintainability. There is a limited set of operators you can overload, and each one corresponds to the name of the function you need to define in your class. However, probably the thing I like the most about Kotlin is the great dev experience offered by its higher-order function support. Lambda expressions can be easily passed as arguments or returned as results. Your code becomes more concise thanks to small syntactic details like dropping the parentheses when the lambda is the last parameter expected or the implicit single parameter. And since we are talking about advanced features, we should probably mention async programming via coroutines. In short, coroutines convert async callbacks for long-running tasks such as database or network operations into sequential code. They allow for writing code that is linear and easy to read while still performing non-blocking operations. If you found this video useful, you should watch one of these ones next. Until next time, thank you for watching.